So literal equations are equations that usually have multiple variables. You see these a lot in your science classes. You'll see it in here when we would do like distance, rate, and time. Literal equations have several variables, and each variable represents something. And so there are going to be times, especially in like a science class, when you are continually looking for one thing. And so it's easier to set the initial equation up for whatever you're solving for so that you don't have to continually be solving back into it. So basically what you do is you handle all of your solving, getting your variable by itself first, and then you just plug in everything and get your answers. All right, and so they give this example, distance equals rate times time, this one right down here. If you're always solving for distance, this is great. You just plug in your rate and time and multiply. But if every time you're solving for rate, or every time you're solving for time, then you're going to have to plug in your stuff and divide, right? Every single time. And so sometimes it's easier to go ahead and get whatever you're looking for by itself, in this case, the time. So they divided everything and they just said, well, if I always want to find my time, then I'm just going to take my two numbers from the get-go and I'm going to divide distance divided by rate. And so this is what a literal equation looks like. We don't have any numbers, so to speak, in here. We're looking for specific variables. So let's look at this first example. F equals W times H divided by L. All letters here, and they specifically want us to get the H by itself. So what we're going to do is we would pretend that everything that we're getting rid of is numbers. What would you do if it were a number? And so you start with the equation that they gave you. And you think about which one they want you to solve for. Well, they said specifically, we want you to solve this equation for H. So what we're going to try to do is we are going to try to get this H all by itself. So we look at some things. What's going on? Well, we have a W that's being multiplied by the H, and we have an L that is dividing the H. All right, and so we're just going to get rid of those by doing the opposite. So if we look at this first one, I am going to get rid of the L. Well, what's the L doing? The L is dividing. How do I get rid of something if it's currently dividing? What do I do? Yeah, so I'm going to multiply by this L. So I'm going to multiply both sides by the L. And on the left-hand side, I have just two variables multiplied by each other, L times F. On the right-hand side, when I multiplied, it actually got rid of the L. Now I have just a W and an H. I'm trying to get the H by itself. What is the W doing? Well, this is multiplication. So if the W is multiplying, what am I going to do? I am going to divide by that W. It's going to cancel. And so my H, when I get it completely by itself, is L times F divided by W. So this is what literal equation looks like. You're just going to do the same process as if it was all numbers and you were solving for that H with all numbers there. Let's look at the next one. This one should be a more familiar formula. P equals 2L plus 2W. What formula is this? So they want us to solve for L. All right. So we have P equals 2L plus 2W. Well, if I am trying to solve for the L, I want to get rid of everything that doesn't have an L first. This group does not have an L. I want to move the whole group over. It is currently being added. How do I move it over? So I'm going to subtract the 2W from both sides. So on the left-hand side, I have P minus 2W. Can I combine those with addition and subtraction? No, I cannot. Why not? Variables. So these are not like terms, so I can't combine them. On the right-hand side, this 2W and the minus 2W cancel, and I have just 2 times L. Is the L by itself?
Yes.
Not quite. There's nothing added or subtracted, but what's happening to it? 2 is multiplying by it. So what do I need to do? Divide by 2. Now listen, when I divide both sides by 2, I have to divide the entire side, not just a part of it. So I would divide the entire side. On the right-hand side, it cancels. So if I have the L by itself, in the numerator, I have the P or the perimeter minus the 2W. In the denominator, I am dividing by 2. And that numerator is grouped, so I can't like reduce anything, it's grouped. Now, it has one more part of this question. Find the L when they give me to these two things. Well, all I have to do is plug it in. I already have the L by itself. They told me P is 58, we're gonna plug that in. They told me W was 6, so we're gonna plug that in. And then we're just gonna do order of operations. Now remember, even if you don't see it, this is grouped, right? So on the top, I have 58 minus 4, this was a 6, sorry, I have to plug in. I wrote a 2, 6. 58 minus a 12, right? And again, this is group, so do the 58 minus the 12 first. So my L should be what? 23. So the first thing they wanted me to do is get the L by itself, and then they wanted me to solve when they gave me the two other pieces. All right. Sometimes you're going to use the distributive property. We're going to look at one of those. If you have any denominators, you're going to multiply both sides by it or clear any fractions like we did when we had our special cases where you got rid of your fractions. Simplify both sides as much as possible. Then you're going to move everything that doesn't have your variable in it to one side and everything that does have your variable in it to the other side. Again, you may have to use distribution and then you may have to divide. So your whole goal is to get it by itself. So we're going to do one that is a little more intense. All right, so for this one, you'll notice they want me to solve for x. Something else you'll notice is that I have multiple x's, right? So which means I need to move everything with an x to one side and everything without an x to the other. So I have the ax minus 5b equals 7x plus 18b. So I'm actually going to move this 7x over here. It's going to cancel. I have an ax minus a 7x. I cannot combine those. Even though I have the same variable x, My coefficients aren't alike. I have an A and a 7. Had it been like a 9 and a 7, I could have combined those, right? But an A and a 7, I definitely cannot combine. All right. And then I have this 5B. This does not have an X, so I'm going to move that one to the other side. Why am I adding the 5B? It's a minus, and I'm moving to the other side. So I do want to do that. It's going to cancel. Don't forget you have an equal sign. Now here I have an 18B and a 5B. Those I can combine. 18Bs, 5Bs, I have 23 of them, right? So then what do I do with this other side? All right, we're going to think of it as distribution. So distribution works two ways. If I have an X with an addition here, remember I can distribute A times X, B times X. It also works the other way. If I have this guy and an X is in each of those, it's the same thing as putting him on the outside and leaving the A plus the B on the inside. You can go both directions with distribution, all right? Either way, you can put it into the parentheses or you can take it out of the parentheses with distribution. So right here, I have an X here and an X here, right? Each of those has an X. Distribution says I can put the X on the outside, and what's left over is going to be this A minus this 7. Those are the same things. If you did distribution, you would get AX minus 7X, right? Equals 23B. Now, what's happening between the X and that group? What's happening over here between the X and the group? It's multiplication, right? How do I get rid of multiplication? Division. You can divide by that entire group. You can divide by the entire group. All right, on the left-hand side, it's going to cancel, and you will now have your X completely by itself. On the right-hand side, you will have something like this. So distribution works both ways, and that's a way to get the X completely by itself. Ratios and proportions. So, a couple definitions here. A ratio is a comparison of two numbers by division and is often expressed as a fraction. Not always, but sometimes. A rate is a ratio comparing numbers with different units. So if they have the same unit, it is a ratio. Usually just numbers here. A rate is when you have two different units, like price per gallon. That's a rate. Because your price and your gallon, your dollars and your gallons are two different types of units, right? And so that would be considered a rate. A unit rate is when your denominator is 1. The example I just gave you is a unit rate. If gas is $3 per gallon, that's unit per 1 gallon. Now, if they said I spent $15 on 5 gallons, that is a rate, but it is not in unit form because your gallons is still 5, right? To get it in units, you have to get that denominator to 1 using division. So you have rates comparing two different units. A unit rate is when the denominator is 1. So they give this example. If a student gets 45 out of 60 questions right on a test, the ratio of correct test questions can be expressed as 45 to 60. You'll notice on all my testing quizzes, you will have a fraction grade on there before you have a percentage grade, right? That's your fraction grade. How many you got right over how many it is. You could reduce that to 3/4. They show different ways to write it. So when I'm asking for a ratio, I will want it in simplest form. So I would want you to reduce it to 3/4. But sometimes you will see ratios written with colons 3 to 4, or actually written out in words 3 to 4. All right. They say that then you could say the ratio of correct answers to test questions is 1/4. All right, 1/4. Two other ratios can be reduced, or incorrect answers rather. So if you were to take 60 minus your 45, you could say, well, I got 15 wrong. If you got 45 correct, you can assume that you got 15 wrong. All right. And then you have a ratio of incorrect answers. And then they said you could have a ratio from answers that were correct to answers that were incorrect. That would be 45 correct to 15 that were incorrect. So you can look at all of this information depending on what they're asking for, and you can get different ratios. If they said correct answers compared to the total number, that's your 45 over 60. If they said incorrect to the total number, that would be your 15 over 60. If they said correct to incorrect, that would be 45 compared to the 15. And so it just depends on what they're asking for. And then they said, how long did it take you to take it? Well, if a student was given 45 minutes to take the 60 questions, the initial rate here is 65 questions to 45 minutes. Or you could reduce it, 4 questions every 3 minutes. If they wanted a unit, they would divide that 4 by 3. So 1 1/3 questions per 1 minute, per minute. So they just took the 4 and divided it by the 3, 1 1/3. All right. And so you can take that same information and produce it different ways depending on what they're asking for. So let's look at example 1. A school of 312 students has 168 girls and 20 teachers. Find the following ratios. So the first thing they ask for is girls to students. Well, that ratio is going to be the number of girls, 168, compared to the number of students, 312. This one actually does reduce. For every 13 students, you have 7 girls, okay? So then they said boys to students, right? Boys to students. Well, you could look at this 2 ways. If I want to know how many boys, I just subtract the number of girls, right? Obviously, okay? So I'm going to have 144 boys compared to the total number of students. This one's actually going to reduce to 6 over 13. What do you notice about these two? They add up to 1, by the way, right? 7 over 13 plus 6 over 13 is 13 over 13. That makes sense if I have compared all of my options. My only options here are boys or girls, okay? So if I've compared all of my options should add up to 1, right? And so you'll notice that once I found 1, I could just figure out what the other one was if those were my only 2 options. Now they ask for it a little bit differently. Girls compared to boys. Well, if I were to look at this one, I'm going to take my girls, which is 168, compared to my boys, which is 144. What do you think that reduces to? 7 over 6. Yeah. So once you've reduced one of these, when you only have 2 options, you've kind of figured it out. Now the last one is they want the unit rate of students per teacher. Unit rate. So the total number of students, that's going to be 312. All right. Compared to teachers, 20. But they want a unit rate. A unit rate. The only way to get a unit rate is to actually do that division. So you actually have to go in and do your division. Now you could reduce it if you want to. It doesn't matter. It's up to you. But you can do your division here. This is actually going to be a decimal, so we have 12 over 20. If you multiply by 5, you're going to get 60 over 100, which is your decimal 0.6, right? So this ends up being 15.6 students per teacher. And what this does is for every 1 teacher, you have 15.6 students. Obviously, you can't have a 0.6 student, but when you're talking about a unit rate, it's okay. All right. unit, okay? So we have 25 or 28 feet, and we want to know how many yards we have, all right? So the basic thought of conversion is whatever you're trying to get rid of needs to go in the opposite spot. So if I have 28 feet, 28 over 1, it's just 28, right? I want to get rid of my feet. So my feet need to go on the bottom because right now they are on the top. Anytime you are getting rid of something, it needs to be in the opposite position of your fraction, all right? Which means my yards needs to go up here, all right? So now I just need to know how many feet are in a yard, which hopefully we all know this. How many feet are in a yard?
3.
There are 3 feet for every 1 yard, all right? So when you are doing conversions, if feet is here and that's what you're getting rid of, it needs to be here. It has to be in the opposite position. So you can do, this is multiplication of fractions. The reason this works is you can cross cancel, right? Which is what you're trying to do. You're trying to cancel out that unit and convert it to a different unit. So in order to cross cancel, it has to be in the opposite position. Had I put it the other way, had I put feet up here, you can't cancel this way. When you're multiplying fractions, you can only cancel top to bottom, all right? Once you've canceled out the units that you're getting rid of, you just multiply across. 28 times 1 yard is 28 yards. I canceled out these feet, so I have 1 times 3. All right? Now, chances are good they don't want you to leave it as 28/3 of a yard because that's just weird. Most measurements are in decimals, I will say. If you were to go into Lowe's and say you needed 28/3 of a yard of something, they would look at you strange, right? So typically they will want these in decimals. You're just going to divide to make it a decimal, right? How many times does 3 go into 28? 9 times. And we are going to have a repeating decimal here, right? Right? It's going to be a 3, and we're going to keep getting a 3 and keep getting a 3 and keep getting a 3. So if I were to round, this little squiggly equal sign means that I rounded to 9.3 yards. So a squiggly equal means that I have estimated it. I have rounded it. 8 minutes into liftoff, a space shuttle is traveling 17,000 miles per hour. How fast is this in feet per second? Well, first of all, we have to figure out what's going on here. We have miles and we have hours. This is in unit. 17,000 miles for every 1 hour. They gave it to it in a unit rate. They want this in feet per second. So the first thing I'm going to do is look at my miles. Where is my miles, in the numerator or in the denominator? It's in the numerator. In order to cancel out, where do my miles need to be? Denominator, which means my feet need to be up here in the numerator. And then I just have to know how many feet per mile, which we just discussed, 5,280 feet for every 1 mile. You can see that that is going to cancel out my miles, which is what I want. They also want to change my hours, right? Hours into seconds, right? Seconds. So I am going to have to convert my hours as well. Where is my hours originally? Denominator. Where do my hours need to go? In the numerator. So now I just need to know how many seconds are in an hour. How many seconds are in an hour? Right, so we have 60 times 60. Anytime you have zeros, just multiply your numbers, throw your zeros in at the end. Shh. We have 36 and 0, 0. There are 3,600 seconds in an hour. All right. Now you can convert minutes to minutes and then to seconds if you want to. You can do a multi-step conversion, or you can just multiply those. There's 3,600 seconds in an hour. Now, did I cancel out everything that I need to as far as units go? Yes. Canceled here. Canceled here. So here's how I check this. I go back and say, what units do I have left? I have feet per second. This is what they wanted. Feet per second. So let me show you a little quick trick here, okay? So we have 2 zeros here in the 3,600. I can cancel 2 zeros out here, okay? Does everybody see that? 0 to 0 can cancel. So while that may not help tremendously, it helps a little bit. I would actually not give you something quite this large, but you're going to multiply 170 times the 5,280 on top, and on bottom you're just going to have a 36.
Couldn't you?
You multiply all this out, they actually round it to the nearest thousands here. 25,000 feet per second. That is going rather quickly, by the way. As if we didn't know 17,000 miles per hour was, but. And a proportion, so these are actually two ratios that are equal to each other. They're saying 7 to 8 is equal to x to 4. All right? Two ratios that are equal to each other. This is where you do cross multiplication. If you can reduce up and down, you do. But with cross multiplication, you cannot reduce across, okay? So, like, let's say this 7 were across from 14. You cannot cross cancel across an equal sign. You can only cross cancel with a multiplication sign. Now, if this were 4 over 8, I can reduce the 4 over 8 to 1 over 2. So I can reduce straight up and down, but I can't reduce across like if I were multiplying them. I am actually cross multiplying, okay? Not cross canceling here. There's a difference. What this is saying is if I were to take the 7 times the 4, that equals the 8 times the x. There's another way to do it too. We're going to do it 2 ways, all right? So 7 times 4 is what? 28. 8x. What's happening between the 8 and the x? It is multiplication, so I am going to divide. So x is going to equal 28 over 8, which you can leave that way, or if you actually divided it out, it's going to be like 3.5. All right? So that's one way to do it. The other way, if it works out nicely, in this case it actually kind of does, you can say, how do I get from 8 to 4? By multiplication or division. What do I do? Divide by 2. Divide by 2. So then if I were to take 7 divided by 2, I would get 3.5, okay? Works out the same, because if I were to reduce this guy, what would I get? I would get 7 over 2, right? 7 over 2. So if I were to do the shortcut and divide by 2, that's fine when it's all numbers. But there will be situations where I have groups. So let's look at this one. So this situation's a little bit different. All right? I don't really, first of all, 5 and 7 don't nicely go from one to the other. All right? If that were 10, maybe I could say, oh, multiply both sides by 2, right? If I were doing normal proportions. But the first problem is I can't get from one to the other nicely. 4 to 8 was a nice little conversion, okay? 5 and 7 are not. There's nothing pretty about going from 5 to 7. You're going to have to multiply by a decimal, okay? The other issue here is my numerator has a plus or minus in it. So remember, when you have a numerator with a plus or minus, those are technically grouped, all right? So when you're doing something like this, you really must do cross multiplication, all right? So I'm going to say the 5 times that group up there, and you have to leave it as a group. 5 times that group will equal 7 times this group. And once again, you want to leave that group just like it is, all right? And now I have an equation that I should be able to solve. I need to simplify both sides. What's my method to simplify those sides? Distribute 5 times x. That is 5x. 5 times 15. That is 75. 7 times x on the other side, 7x. 7 times 9, 63. Those are as simple as they get on either side. So now I'm ready to move my variables and move my numbers. Move all your variables to one side. So if I subtract the 5x, I need to do it on both sides. It will cancel here. It will be 2x here. If I moved those over to the right, that means I need to move my numbers over to the left. So I'm going to subtract the 63 from both sides, right? And I am going to get 12. So I have 12 equals 2x. What's my last step here to solve for x? Divide both sides by 2. So what does my x equal? 6. You can plug it in. You can say 6 plus 9 over 5 equals 6 plus 15 over 7. 15 over 5 equals 21 over 7. 3 equals 3. Yes, 6 was the right answer. All right, so let's try some of those. One has a group, one does not.